Welcome, everyone. It's hard to believe we're already halfway through the 2022 year with our webinar, but we've had a great lineup so far, and we're going to continue strong. Our first speaker is Dr. Juang Horng, or as we know him, JC, who is a professor and extension specialist of turf and ornamentals entomology at Clemson. JC joined Clemson University in 2007 after completing his master's and PhD at University of Georgia and a postdoctoral training at University of Florida. His current research and extension program focus on developing practical and effective pest management tools and approaches for turfgrass and ornamental plants. JC, the floor is yours.
Thank you, Bodhi. Let me put that presentation up. How are we looking?
Perfect.
Great. All right, everybody. Today we'll be talking about, at least for my session, talking about insecticide and miticide. And in the green industry, basically, greenhouse, ornamental, landscape, turf, ornamental, anything you consider is something that's pretty. Insecticide and miticides are very important when it comes to managing pests. So understanding how they actually behave or what they're supposed to do will really help you decide what particular insecticide or miticide you want to use in your operation. That's what we're going to be talking about today. But before that, I'll give you my contact information. There's my email address on this screen right now. And feel free to send me any questions about insect management. I don't know much about diseases. Jim will talk some about that. I don't know anything about weed, to be honest. But when it comes to bugs, I'm pretty dang good, I think. Any questions? Feel free to send it to me. And also, if you like a copy of today's presentation, also send me an email. Let me know, and I'll get that to you. But anyway, so what we're going to talk about today, really just try to think about insecticide and miticide and how they actually function and what is actually available to you when it comes to managing pests and mites as well. But when I put this particular presentation together, it was put together as a 3-hour course. So obviously I cannot talk everything about insecticide in these 30 minutes, but I'll do my best. The central goal of my presentation today is really give you enough information to actually build a pesticide rotation program. Pesticide rotation program, it doesn't matter if it's insecticide, miticide, fungicide, or even herbicide, is very important in maintaining the efficacy of all the pesticides that you are using. The more careful you are with rotating miticide and insecticide, the longer you're going to have a product available to you. So that's very important as far as our business is concerned. So let's move on to the first part of our presentation today. And the first thing I want to talk about is really this term mode of action. Some of you probably heard of mode of action before. In the simplest sense, the mode of action of an insecticide or miticide or any kind of pesticide for that matter is the way how a pesticide actually kills a pest. For example, in this particular figure is hydrometronone. The trade name of it, you're probably pretty familiar, is actually called amdropharium-based. What hydrometronone did is that this active ingredient works on cytochrome, which basically block off the energy production system of an insect and therefore kills the insect. So that's what mode of action is. It's basically how an insecticide or miticide actually kills a pest. So when we look at all the insecticide and miticide out there, we can group them together in five major targets as far as what kind of system that actually works to deal with insects. The first one is nervous system. That would also influence muscle and all. So this particular group is a big group of insecticide actually mess up the normal nervous function of an insect. And therefore, the insect basically just die from either overexcitation or not enough excitation, or they cannot fly or they cannot feed or something. Either way, you mess with the nervous system and then they cannot function properly and then they die. The second group, another big group, is are the insect growth regulators. Insect growth regulators are basically chemicals that actually block the normal reproduction or development of insects. And therefore, they never become adult, they never reproduce, and therefore they die. And the third major target is respiration and energy production. And this is one group that typically focus on particular cellular processes in mitochondria that actually destroy that particular process. And therefore, the insects can no longer produce energy. When they cannot produce energy, they become lethargic and then they just die. And the next group are basically sonic midgut. They basically rupture the midgut, and there's only one of them there, but we'll talk about it in later on. And there are a lot of other insects out there. In fact, we don't even know how they work. So they are either unknown or not very specific as far as what they are dealing with. So there's quite a few of them out there. Let's say the first group deal with nervous system. And like I say, there's a lot of them. And a lot of these are actually some of the ones that you are more familiar with. For example, sodium channel modulators or protoportal organ channel modulators and things like that. And this continue. These are also the insecticides that deal with nervous system. So as you can see, most of the time, these insecticides are either dealing with a sodium channel in the nerve or with some kind of receptors in the nerve. And therefore, they basically mess up the normal function of the nerve cells. And therefore, the nerve can no longer function properly and they cannot serve the purpose that they're supposed to be doing. The insect growth regulators, on the other hand, there are quite a few of them. Usually, the insect growth regulator or the mite growth regulators typically mess up with some kind of hormone or chitin biosynthesis within the insect. And therefore, the insects that got impacted, usually they do not develop to adult. Or when they try to develop, their body sort of deform and something is going to happen to them and then they basically die. And some of the insect growth regulators also stop reproduction of insects as well. And these are the groups that actually stop the cellular respiration or energy production in the insects. And most of the time, they are targeting some kind of process within mitochondria. Either it's complex 1 or complex 2 or complex 3 electrotransport inhibitors. And the group that deal with the midgut are the basically 11. And in this group are the Bacillus thuringiensis or BT. And we'll talk about them in a little bit more detail. And these are some of the ones that we don't really know exactly how they function or they are not classified. Acetylcholinesterase is one of the ones that nobody really know exactly how it works. Now, you read about and you read a lot of things online. You probably see something like acetylcholinesterase is like insect growth regulators. Yeah, it has insect growth regulators activity. Or you would read that, it would actually stop them from feeding or repel them. Yeah, it have anti-feeding or repellent activities as well. So acetylcholinesterase is one of those chemicals that actually probably have multiple ways how they actually works with insects. So in that case, they are not particularly specific. And therefore, they're pretty hard to classify as far as what they are. And other things such as lime sulfur or sulfur, typically even though they have been used for hundreds of years, we still don't really know exactly how they work. As for pathogens, for example, bacteria or fungus or viruses or nematode that we actually use to control insects, or oil or soap or some kind of peptide or essential oil, things like that, they are not currently classified at all based on their mode of action. And again, most of these pathogens or essential oil or soap, they probably works very differently. They're probably not working with the nervous system. They're probably not insect growth regulators either. So it's pretty hard to actually classify them. So right now, they're not classified at all. So like I say, there are a lot of different mode of actions that's out there. The last count in the insect world, we have about 35 mode of action. Can anybody remember all of them? I can. And I'm doing this for a living, so there's no way I can figure it out. But there are some very smart people that get together and try to figure out a way so that we don't really have to remember all the this long names for this mode of action. Instead, they figured out a system for us to actually use the information without really have to think about it. Some of these folks are basically in the group called the Insect Resistant Action Committee, or IRAC. You probably heard that before. And for fungicide, there's a Fungicide Resistant Action Committee, or FRAC. And for herbicide, the system that we use in the US are typically the Weedicide Society of America, a classification system. So it's WSSA. So there's a lot of difference. So whatever they do is that all this IRAC and FRAC or WSSA, what they do is basically look at all the chemicals that we have, group them by the mode of action, and then give them a specific number and a letter. But anyway, if you want to know more about mode of actions that we use in the green industry, that is more than what I can tell you today. I have a great document for you to go look for it. And you can access that online from University of Tennessee, and link to that particular document is right here on the screen. It's document W415, the Insecticide and Miticide Mode of Action Field Guide. Basically, this particular document, I think, is about 85 pages or something like that. It basically tells you the history of the mode of action and actually how the mode of action actually works, what kind of insecticide actually in there. So it could be a pretty useful thing for you to have if you actually want to know how a particular insecticide actually works. So that's a great document for you. And if you have insomnia or you just can't sleep, this is a great document to help you sleep as well. Read a few pages, it'll knock you out very quick. But anyway, so most of the time, mode of actions are actually classified in a very organized way. Like I say, in IRAC, at least, that what we have is typically a number and a letter. The number itself indicates a unique mode of action. For example, group 1, the mode of action is acetylcholinesterase inhibitor. Group 2 is GABA-Gated or chloride channel antagonist. Right? So basically, the number will tell you what mode of action, but the letter actually tells you what kind of chemical class they are in. For example, 1A is carbamic, 1B is organophosphate, and basically 4A, neonicotinoids, so on and so forth. So when you actually think about rotating insecticide, we are looking at rotating among different numbers. We don't consider the letters at all. The letters are basically just another layer for us to classify them. And this is a typical FRAC table. Again, FRAC typically classify all the fungicide by letter and also by numbers as well. This is a WSSA table. And again, they classify different mode of action by number and letter as well. So all of these are really to try to help you understand what kind of mode of action without trying to think of the entire name of that mode of action. For example, amino acid biosynthesis inhibitor. It's pretty long. Most people probably don't try to remember it. Understand these numbers, and you can go to this organization to download the mode of action table. But there's an easy way to do that. You don't need to do that if you don't want to. The easy way to do it is actually look at your insecticide label or your pesticide label. In some of the newer product or newer label that we have now, typically the IRAC or the FRAC or the WSSA code numbers or group numbers are actually on the first page of that label. So when you see a lot GCSC, that's a trade name, and the active ingredient, and you can see that it is a combination of chloride, which is a group 4A insecticide, and bifenthrin, which is a group 3 insecticide. So if you look at the first page, you can just look at that and say, all right, this is a product that is a combination of 2 insecticides. One of them is 4A, the other one is 3. So that's very easy for you to determine what you actually have. And one thing I want to mention is that today I'm not going to talk about what insecticide is good for what pest. I'm not going to talk about that. I don't have a whole lot of time to talk about that kind of stuff. But because what I want to focus on really are the mode of action, how insecticide actually kill bugs. But if you want to find more information about which insecticide is best for what ornament, what pest, there are several things that you can get. This is a new poster that CPRO have asked me to put together. You can go to the link over there, cpro.com/blog poster, and download a copy of that. That is a 2023 insecticide guide. So I basically organize the table by the IRAC number and then the active ingredient, select the trade name, use site, REI, and then what particular insects it is labeled for. Okay. Hopefully that is an easy enough poster that you can just stick on the wall. And if you've got a thrips, you can just go to that poster and say, what can I use to control thrips? So hopefully that will be relatively easy for you to use. And of course, on turfgrass itself, don't forget, every university basically have a pest management guide. Georgia is no exception. This is the insect control in commercial turf document in the Georgia Pest Control Handbook. So you can always go there, look at what kind of pests you want to deal with, and the insecticide that's available to control them. For example, if you want to control red imported variants, and you say, I want to try bait. And there you go. Go to that table, and you're going to realize that you have 4 different kinds of bait: Avian, Siesta, Ampro, Extinguish Plus. So that's what's available. You can take a look at them, see what you have, or see what suits your pluckers the best. All right. The next section of what we do is basically going through some tables. Like I say, I won't be able to talk about all the groups. So I'm just going to talk about some of the groups that I think folks are using a little bit more. The first group I want to talk about is the chlorinesterace inhibitor, or group IRAC group 1. And there are 2 subgroups within it. The first one is carbamate, or 1A. And the second group is organophosphate, 1B. So among all these chemicals, you probably see a lot of things that actually are very familiar to you. That's because group 1A, the number 1, indicated it is a very old group of chemical. So right now in the green industry, we have not as many as what we used to, but you can still use 7, orthine, merithion, dialox. And until last year, we still have Thurspan on the list. And now Thurspan is gone. All right. So anyway, group 1, or acetylcholinesterase inhibitor, is a nerve poison. So it basically works on the nerve. Now, this is a very old group of chemicals. Merithion was first introduced in 1950. And carbamate, or 7, was actually introduced in 1956. So they've been going back way back when. But they have a much darker history, if you want to put it that way. They were actually derived from nerve gas research during World War II. They are actually developed to try to kill people, but they also worked on quite well on insects as well. So after the war, basically this particular group of chemical has been, I guess you can call it, converted into being used for agriculture use. When they are used in agriculture, their benefit becomes very apparent very quickly. This particular group of insecticide are very broad spectrum. Okay, most of them are contact insecticide. Some of them are also locally systemic. For example, orthine. You can actually use orthine almost like a systemic insecticide. But there are some really nasty side effects from group 1 insecticide. That's because, remember, they are developed as nerve poison. They are developed for killing people. So a lot of them actually have very high mammalian toxicity. And therefore, if you look at any kind of organophosphate insecticide label, for example, orthine, you're going to see that the REI, or re-entry interval, is 24 to 48 hours. So it's very long. And it can kill a lot of things. It will kill cockroaches, and it will kill mosquitoes, it will kill spider mites, it will kill thrips. But you know what? It kills people too. There's a lot of restrictions that's being put on it, and there's a lot of cancellation in the past. So I expect we are not going to have group 1 insecticide with us for a very long time. Over the time, they will eventually be replaced by some of the newer insecticide, or their registration will be canceled down the future. And another thing is, because they kill so many things, and of course, they also kill bees and parasitoid and all kinds of stuff as well. All right, group 2 are the GABA-Gated chloride channel blockers. And we have basically 2 subgroups within this mode of action. The first one is 2A, which is clodane or endosulfate. If you've been around for a long time, you probably remember clodane. We don't have those anymore. Those are very highly toxic insecticide, and therefore they are taken out. The only one that's available to the green industry right now is fipronil. Fipronil is basically the active ingredient for top choice for flowers, and great for fire ant management or mold cricket management on turfgrass. And that's the only one that is available at the moment. And again, group 2 is a nerve poison. They also have very long history. For example, endosulfan was introduced in 1956. Fipronil was introduced in 1987, and it was commercialized much later. Right now, in the green industry, the only use for fipronil is basically in turf to control mold crickets, ants, fleas, and ticks. They are contact insecticide, and some of them may be locally systemic, but the systemic ones are no longer available. Fipronil is probably one of the best products that I can suggest when you're thinking about controlling mold cricket or fire ants. That's because they have very long residual activity and they basically stay in the soil for a very long time. Now, that's a good thing if you have a long residual, if you want to control soil pests for a long time. But it also causes problem when you have the residual being around for so long that you cannot get rid of it. So we are probably looking at losing group 2 insecticide in the not too distant future, I think. This is another group that we may be losing in the green industry. Group 3 has a very long list, and because this is basically the workhorse of the green industry. And group 3 includes some of the chemicals that you are very familiar with, for example, bifenthrin, cyclothrin, deltamethrin, permethrin, that kind of product. And all of those are basically pyrethroid. Pyrethroid right now is probably one of the most commonly used insecticide that we have in the green industry. You can use it for just about anything in some way. And group 3 used to include DDT. Of course, we don't have any DDT product available at all. And again, pyrethrin or pyrethroid for that matter, pyrethroid is actually a synthetic pyrethroid. Now, pyrethrum has been used as a natural compound since 100 BC. So it has been around for a very long time. But the only problem with pyrethrum is that it has a very short residue. You extract it, you spray it, and then it breaks down in a few hours under sunlight. So it's not very stable. It's very effective as knocking down insects, but it's not very stable. And therefore, pyrethroid was developed in the 1940s to try to replace the pyrethroid. And today we have about 45 different pyrethroids available, but only a few of them are actually registered for use in the green industry. Now, you can use pyrethroid to control a lot of different insects and mites. So they have very broad use, and their efficacy is only for contact. And if you're going to use a pyrethroid insecticide at all, you want to make sure that your spray coverage is very good so that you can achieve pretty good efficacy. And one great thing about pyrethroid is that they have very quick knockdown, meaning that you can just spray on the insects and the insect basically will kill over within an hour or two. So and also they're very effective. And another thing is that they have very, very low mammalian toxicity. And so their REI is pretty short. And because they're widely available, they have broad spectrum activity, and therefore they're being used in all situations. And they've been overused for sure. And pyrethroid is basically one group of insecticide that probably has the most example of pesticide resistance from them because we use it so much. This is one group probably going to stick around for a very long time, but I typically recommend that we don't use too much of the group 3 insecticide simply because we use it too much anyway. So think about that. And also, they are not compatible with natural enemies and bees. And one of the most common products for use to control mosquitoes is pyrethroid. Pyrethroid used to knock down mosquitoes, but they also kill a lot of parasitic wasps that attack scale insects. Oftentimes, what we are seeing is that when we use pyrethroid to control mosquito in a mosquito spray program, we ended up having scale insect outbreak simply because the pyrethroid kill all the natural enemies of the scale insects and a lot of scale insects that go bananas. That's something that you need to be aware of. Group 4 insecticide is not a workhorse for our industry. Again, there's a lot of them in group 4, especially recently, but the most famous one among group 4 is probably the neonicotinoid. The neonicotinoid of 4A That would include chloride, orina, diloteprin, safari, imidacloprid like mirid, dimethoxin like blackshear, and acetate tristar. But we have some of the newer product as well, C, D, E, and F. Those are some of the newer product that is very similar to neonicotinoid. They have the same mode of action, but chemically a little bit different. For example, sulfoxaflor. Sulfoxaflor is one of the ingredients in the product called Expire. Pyridifuron, that is the active ingredient for Altus. Both Expire and Altus are registered for use on ornamental plants, both indoor and outdoor. So they actually have quite a bit of use in the US. So a lot of nursery growers, a lot of greenhouse growers, when they are requested by their client not to use neonicotinoid, a lot of them are actually changing over to 4C or 4D, basically using Aspire or Altus as a replacement for neonicotinoid. And again, neonicotinoid or group 4A is a nerve poison, and neonicotinoid, like pyrethroid with that OID, oid, behind the name, basically it means synthetic. A neonicotinoid is a new synthetic nicotine. We have been using nicotine for controlling insects for a very long time, but nicotine has a very nasty property of being highly toxic to mammals. So anybody who try to extract nicotine and spray them, if you're not careful, they might kill themselves. Nicotine, even though it has been used long time ago, we don't use them now. Instead, neonicotinoid were developed in the 1970s to replace nicotine, simply because neonicotinoid is so much safer to mammals than the nicotine itself. So neonicotinoid, they were discovered in the 1970s, but the first one of imidacloprid was not introduced until 1997. And everybody else after that in the year 2000. So they've been around for 20 odd years. They are very popular when they first introduced, mostly because they have very broad spectrum activity, especially against sucking insects. That's because neonicotinoid is a systemic insecticide. So when you apply it to a plant, to the root zone, the plant will soak it up and then bring it up to the leaves, bring it up to the other parts of the plants, and the sucking insect that's sucking the juice from the plant itself will ingest the toxin, and then they got killed. It is actually used quite a bit for controlling sucking insects, especially in the landscape. Because in the landscape, if you try to spray a 35-foot oak tree, it's just about impossible. But you could apply neonicotinoid or one as a semi-insecticide to the root zone of that 35-foot oak trees and let the tree take it up, and therefore you control the sucking insects. For example, scale insects indirectly. Makes the application a lot easier. So again, neonicotinoid has a broad spectrum and particularly effective against sucking insects. It has systemic activity. And something that we've been working on in the past is basically looking at different application methods for neonicotinoid. You can apply neonicotinoid as sorbents. You can spray them. You can do trunk injection with them. You can do floor injection with them. There's some granular formulation, or you can just mix a thicker product and apply it to the trunk. Either way, the plant will soak it up. So some of the work that we have done years ago, looking at scale insects, is looking at different kind of application method, basically showing that it doesn't really matter what kind of application method of neonicotinoid you use. They're equally effective because they're so mobile inside the plant. They can soak it up, bring it up, and control the insects. They have a relatively short REI, about 12 hours. But like I said, neonicotinoid used to be a very highly popular product. But in the past few years, you can say the light has dimmed a little bit. That's because there's a lot of concern about the toxicity of neonicotinoid to pollinators. And especially because the neonicotinoid is a systemic insecticide, it will be soaked up. The active ingredients will end up in the nectars and pollen, and therefore ended up impacting the health of the pollinators. So if you are using neonicotinoid at all, there's something that you need to be thinking about, which is try to follow the label instructions so that you can minimize the impact on the bees and other pollinators. All right, group 5, very similar works. You got neonicotinoid, acetylcholinesterase receptor, but there's only one group in this particular mode of action, which is spinosad. Some of you probably heard of spinosad before. Conserve is a product that has been around for a long time. Recently, we have a relatively newer active ingredient called spinetoram. Spinetoram is one of the other ingredients in Expire. In fact, you probably know that spinosad is actually considered organic. Some of the products are actually considered organic. That's because spinosad is actually a metabolic byproduct of a bacteria fermentation process. Originally, the product itself can only be get by fermentation of that bacteria, and then we extract that active ingredient from that fermentation product. And therefore, they are not actually produced from petroleum, and they are considered organic in that sense. Spinosad typically have a broad spectrum efficacy, but in my experience, they are particularly effective against caterpillars. They have both contact and stomach activity. And most of the time, spinosad is considered a reduced risk because the host range because target range is relatively narrow. And also, they're considered organic insecticides as well. But they have been overused for quite a bit, especially when it comes to the thrips management. So some of the resistant issues have already developed in some areas where thrips have become resistant to spinosad or considered. Group 6 is Abramactin. Abramactins, there are several Abramactins in there, and Abramactin is one of them. Abramactin benzoate is one of them. Milbemactin is another one. Abramactin is probably the one that you're most familiar with or avid. In fact, you've probably seen Abramactin in your flea treatment for dogs as well. So they've been used in a lot of arena, not just in turf and ornamentals. And Abramactin was first identified as a byproduct of metabolic byproduct of a bacteria. But during the process of developing this product, it turns out that it's cheaper and easier to actually develop Abramactin from petroleum. So now most of the Abramactin was actually produced as from a petroleum product. And therefore, Abramactin is not actually an organic insecticide, even though similar to spinosad, they have their origin as a byproduct of bacterial fermentation. Anyway, Abramactin has a very broad spectrum activity. They are particularly effective against mites. Some of the products also have efficacy against nematodes as well. And one of the interesting things about Abramactin is that it actually has a translaminar activity. What I mean by translaminar is that it's almost like locally systemic. It's not going to be soaked up by the plant and take it up to the rest of the tree like a neonicotinoid, like a systemic insecticide. But translaminar insecticide, what they do is that if you spray directly on the top of the plant, the active ingredient will penetrate into the plant tissue itself and kill the insects that's feeding on the underside of the leaf. So it's almost like a locally systemic, so they can actually get into the plant, but they are not going to follow the sap of the plant and go all over the plant itself. So they are not systemic. Translaminar activity actually will give you some benefit in controlling some of the hard to reach insects and mites. For example, spider mite that's feeding on the underside of the leaves. You can apply it a little bit on the top, and then the mite on the bottom can be poisoned that way. But even with that translaminar activity, I would still recommend that if you're using it to control thrips or mites or whiteflies, you want to make sure you get pretty good coverage of your plant. And they have a relatively short REI. And one of the things about Abramactin is that they are not particularly compatible with bees and wasps. Therefore, if you have practiced biological control program using parasitic wasps for, say, whitefly or aphids, Abramactin is something you don't want to use because it will really mess up your biological control program. Group 7 are the juvenile hormone mimics. And again, this is basically chemicals that mess up the reproduction and the development of insects. There are quite a few of them in here. And group 7, we have extinguish of metroprene, and quinoprene is N-star, which is registered for use in greenhouse. And pyriproxyfen have used both indoor and outdoor. as a distance IgA, distant IgR. Distant IgR is basically a sprayable product, and distant variant bait is a bait. And it has been basically developed since the 1960s. Basically almost like a replacement for organophosphate and carbamate. So they have been developed way back at that time. And we have used them for quite a bit. In the turf industry, we typically use them for fire and bait, simply because you can put it in the fire and bait, and fire will carry it home. And then when parents share food among nestmates, including the baby, will feed on those juvenile hormones, and then they cannot develop. And therefore, the colony basically have no more ants, adult ants that they can use. And that's a very good way for you to actually achieve long-term suppression of fire and colony. They also have very low mammalian toxicity. And they are compatible with most of the natural enemies and bees. And therefore, they are very good as a replacement for a lot of other insecticides for use. But one thing you want to remember, which is that group 7 or juvenile hormone mimic only works on immatures. So if you have a population of pests that's mostly adult, this particular group may not be the most appropriate product. All right, group 11. Group 11 is basically Bacillus thuringiensis, or BT. There are different subspecies of BT. For example, Kerstaki, Isowari Kerstaki are 2 subspecies, and they are very specific for caterpillar, and that's in the products such as grub gone, and that's more specific for white grubs. And Israelensis, that is in the product called natural, and that's used for controlling fungus gnat or other flies. And therefore, Bacillus thuringiensis, when you're going to use them, you need to understand what particular subspecies that you have. And so you can choose the right one for the right pest. And there are more than once I have heard folks telling me that, oh, I have fungus gnat, so I decided to use Dipel. And I was thinking, okay, Dipel is subspecies Kerstaki. Kerstaki is only effective against caterpillars. So if you try to use Dipel to control fungus gnat, and fungus gnat is a fly, that's not going to work, right? So even though they are BT, they are the same species, but because they're different subspecies, they have different whole spectrum. So you need to understand what particular subspecies that you have and use it to control the correct insect. And BT is basically a bacteria that live in the soil, on deep surface, or in water. They are basically everywhere. The insecticide that we have now basically a product of development since the 1920s. So basically, these are spores of the BT that you can mix and spray. And what happens is that when the caterpillar come by and eat on a piece of leaves, and they will ingest the spore of the BT. So the BT go into the stomach of the caterpillar, and the pH level in the caterpillar's gut basically makes bacterial spores germinate. When they germinate, they start to cause disease within that insect. That's where the specificity actually comes from. Now, again, I mentioned earlier about pest spectrum. Each subspecies have a very specific host range. So you need to know what subspecies you're using and what target they might be targeting. And always remember that efficacy of the BT product is always greater when you're using it to control small insects. So if you have a bagworm infestation, you could use BT to control it, but it's probably best to use the BT at the beginning of the infestation stage, where the bagworms are still really small. Big bagworm can still be killed, but probably not going to be as effective as when they are small. All right, group 20, I'm going to jump ahead. Like I say, I cannot talk about every single one. But group 20, I want to mention them because within this group, we have several miticides. For example, shuttle or esquinacil and bifenazate, loramite, these are actually miticide. Hydromethanol is another product that I mentioned earlier, which is the active ingredient of Amdro, fire and bait. So there's quite a few insecticide and miticide of them in this particular group. And what they do is that they will target the electron transport chain within mitochondria. So they mess that up, and then the insects can no longer produce energy for their own use, and the insect will just die. So one of the products we are used a lot now in turfs is for firing control. For ornamentals, most of these products are actually used for as miticide, and they have pretty short REI, typically 12 hours or less. Group 28 is probably one group that has most excitement these days, because this is one group that has a few more new products that has been introduced in the past few years. Group 28, that includes products such as Acetylcholinesterase, mainspring, Theresa, and Tetrino. Theresa was introduced maybe 2 years ago, and Tetrino was introduced last year. So this is one group of insecticide that probably going to have a few more new products coming out in the next few years. So interesting stuff. Anyway, they are also nerve poison. What's interesting about group 28 is that they are actually alkaloid that was originally discovered as an alkaloid by the Rhinodex species, by a plant. It's a plant extract that further developed, and then the molecular property got changed a little bit. There are several products that have been introduced since 2008. They are very effective against caterpillars and also white grubs. This is one group that I would definitely recommend if you are dealing with full armyworm or white grubs or anything like that. I celebrate parents, Tetrino, and those would be the typical product that I would recommend for controlling caterpillars and white grubs as well. And they are actually systemic insecticides, but they are not as fast moving as the neonicotinoid, and therefore they can be used as a replacement for neonicotinoid, but you should expect them to have very slow activity. And you should be using them more like a preventive insecticide instead of a curative insecticide in some way. All right, there are several unknown mode of action. Azadirachtin, as I mentioned earlier, is one of those. And another one that I typically want to mention is Pyrethroid or Overture. Overture is a product that's only registered for use in the greenhouse. It is probably one of the best products that I have for thrips control. But anyway, let's focus on azadirachtin as itself. Azadirachtin has been around for a long time. It's an extract from neem tree. Right? So neem tree has been used for pharmacological and also for pest control purposes way back when, 5,000 BC or more than that. But the real structure of azadirachtin was only determined in the 1960s. And they are extract from seed and kernel of neem. Like I said earlier, they have pretty broad spectrum activity, but we don't really know exactly how they work. They may be insect growth regulators. They may be stomach poison. They may be contact insecticide. They may be a repellent. So there's probably a lot of mode of action mixed in it. And they're pretty broad spectrum, but they're more effective against soft body insects, for example, aphids or spider mite or something like that. Some of them actually have a little bit of systemic activity, but certainly not as systemic as neonicotinoid. And most of them are considered organic insecticide. All right, I'm going to skip all that. But one thing I want to really mention is that I mentioned all these insecticide and all that really is a way to let you start thinking about developing a pesticide rotation program. Now, what is pesticide rotation? Pesticide rotation is basically when your chemicals starting to fail. And we have a real life example of that in southern chinchbugs, especially in southern Florida, where they have been known to develop resistance quickly to a lot of different things, from DDT in the 1958 to imidacloprid in 2007. So they are very good at developing resistance. And that's because we keep using the same thing over and over and over again. For example, landscape care professional A wanted to control southern chinchbugs. Every year, he used pipenthrine. The first year he uses it, he kills 90% of them. Second year he kills it, it becomes 80%. Third year he kills it, becomes 60%. And every year he uses it, the efficacy of the insecticide continue to reduce. And eventually, it's going to have a resistant population popping up. And really, the best way for you to actually stop that from happening is to develop a insecticide rotation program. It is actually not very difficult to develop an insecticide rotation program. And what I typically would say is you want to follow the number. What I mean by that is that, okay, think about numbers. I mentioned all these IRAC number, right? So you can develop a rotation program by rotating from one number to a number, another number to another number, a different number. So for example, landscape care professional bees, he wants to control chickenpox as well. But Mr. B is the lost martyr. In year one, he used pyrethroids. In year two, he switched over to acetate, which is 1B, which is a mode of action group number 1. And then year 3, he used chloride, which is group number 4. And then year 4, he switched back to pyrethroids. You see what he's doing? Basically, what he's doing is every time or every year, he uses a different kind of mode of action to deal with the southern chickenpox. So the southern chickenpox population never really have a chance to develop their resistance because it's been challenged by different mode of action at different times. So you never have a chance to fix on something and become resistant to that. So the best way for you to develop a resistant program is basically rotating from one mode of action number to another mode of action number to another mode of action number. So every time you do that, make sure you pick up your insecticide label, look at the first page, and see if you can find those group number or not. If yesterday you use a product that has 4A for the same pest, you probably don't want to use 4A again. You probably want to switch it to another group. Right? So that's how you actually rotate pesticide. And there's a lot more information to that as well. If you have more questions about rotating insecticide and all that, feel free to put a question in the chat box and we'll talk about them. All right, that's all I got.
Thank you, JC. This was really wonderful. And I couldn't help watching the numbers on your slides and realizing, wow, he's got so much more to talk about. And I really want to hear it all. So we're going to plan on you coming back again and going through the rest of those slides.
Well, like I say, that is a 3-hour program. Any questions? Anybody?
I'll get us started. It was really interesting to see how many different groups have been developed. I just have never really realized that there were how many of them? Like 28. I think you ended up with 28.
Right now we're looking at probably 35.
35. Wow. Okay. Yes. Yeah. We definitely need to know more about these. It's really important to keep talking about the developing a resistance in those pests as we seem to have more and more pests. And the weather seems to be triggering earlier and earlier pest population development. And so I really want to emphasize how important it is for us practitioners to know about these best practices to rotate different modes of actions and to understand that this is a long-term process that we also need to keep records and just knowing what we've used in year 1 and plan for the same pest through year 5.
All right, we have several questions popped up. It seems like the first one is by John, and he was asking if product that has been used for disease control, can that undermine the efficacy of some other product such as BT? And that is a great question. And therefore, when we are thinking about selecting insecticide or selecting fungicide, it's not just one thing at a time. We need to think about it holistically. So basically what it is that if you are using BT product to control caterpillars, you probably want to stay away from any kind of copper product or fungicide that have efficacy against bacteria, simply because BT is a bacteria, right? If you apply the BT as a bacterial product to control your insects, but you ended up using another product that can interfere with this activity, not good. The same thing with a lot of fungicide product as well. For example, Botanicard is a fungus that will kill insects. You can use that to control a lot of insects. But if you're using that, you probably want to hold off on using fungicide, simply because the fungicide will actually interfere with the activity of Botanicard. So not just insecticide, but also fungicide. You really need to think about how they interact. But most of the time, if it is not a biological product, you don't have to worry about its combination with fungicide or any other product at all. But if you're using a biological product, that's one extra thing that you need to think about. All right, there's another question in the chat box actually. Do combination of products speed up the development of resistance? That is also a very good question. Basically, a lot of time particularly in the landscape industry, we try to combine a lot of things to control a lot of different things, right? Because you want to make sure you go out there once, you take care of all the problems already. So how is that going to interfere? How is that going to end up helping or reducing the development of resistance? In some way, the jury is still out on that. So my personal preference is that if we are talking about tank mixing different kind of insecticide, I usually discourage that unless there's a good reason for it. The good reason would be that if you are using the combination of different insecticides to deal with different life stages, or if you're using the combination to deal with different kind of pests. For example, if you have a population of thrips and spider mite at the same time, you might want to combine an insecticide and a miticide together so that you can deal with two pests at the same time. Now, that makes sense to me, but it still doesn't get away from the requirement that you want to rotate them to something else in the next spring. All right, another question we have is acephate theme. Is acephate or orthene labeled for residential turf in Georgia? Now, that is a question that probably shouldn't be answered because that is what is registered for Georgia. Yeah, you might want to call Sheman Joseph for that. I would defer that to Sheman. I'm much more familiar with what we have in South Carolina. And of course, on the label, that's where you want to find that information. If the label say no residential use, then well, no residential use. All right. So last question, is there a BT product for mosquito control to use in mist blower? And the answer is no. Not that I know of, I should say. Now, the reason why there's not really something for the mist blower is because first, mist blower, we're using that to spray for adult mosquito, right? But what do BT kill? Larvae. They don't kill adults. So if you actually use a BT product in a mist blower to try to control adult, that's not going to work. But you do have mosquito biscuit or something like that that you put in water, and those are actually for controlling larvae, not adult. Okay. All right. How about time we're looking at?
We have only 1 minute.
So 1 minute.
Questions that popped up. Talk fast.
All right. Let's go to the question from Tyler. All right. In my best opinion, do I think armyworm will be as severe as last year? What product do you recommend best? Only time will tell. I think it probably will be comparable to last year, and that's just my guess. And in fact, today there's an email coming through my mailbox that's saying that we already have a full armyworm outbreak in Greenville, South Carolina. We're already starting to see them. But I think we're probably going to have a pretty bad year as well. So what is the best product that I typically recommend for turf? My recommendation would really be the diamides. Acetylcholinesterase or ferrets would be great, or tetrino would be great. And typically what we're recommending is if your full armyworm love to lay eggs or anything that's sticking up, like the wall or fence posts or anything like that, and also tree line. So at least for golf turf, what we typically recommend is spray a band along the tree line, because that's where the caterpillars that's where the moths are going to lay eggs, and the little guys are going to come down the tree trunk and start feeding on the grass. So if you apply a celebrate along that line, you're basically stopping them from getting into the turf. If you could yourself use a acetylcholinesterase, that would be great. And some of the work that we have done is showing that comparing different kind of product. And we're like, okay, let's try bifenthrin, which is what everybody uses and very cheap. You spray it once and it lasts for about a week or two. If you apply acetylcholinesterase, it lasts at least 2 months. 2 weeks, 2 months. Can you find enough people to spray every 2 weeks? Probably not. So I would say go with a much longer residual product by acetylcholinesterase. That probably give you the best efficacy when it controls.
Thank you so much, JC. Again, we're going to count on you coming back and going into more and more details on this really important subject. So thanks a bunch, and let's take 5.